Section 3.4 is changes in chemical matter. This is going to be very, very similar to the section about chemical and physical changes. Physical changes are when you have a change in a substance in which the chemical structure does not change. So the substance is the same in the beginning and the end. A chemical change then is a change when the chemical structure of the substance changes and you end up with something different than what you started with. Physical changes do not produce anything new. So here are some examples. Breaking. So if you drop a beaker on the floor, it's going to break into a lot of pieces, but it's still a beaker. It's still made out of glass. Dissolving, we talked about with physical and chemical properties, where if you dissolve salt in water, it's still salt. You can get it back. It hasn't changed what it is. Distilling just means you're separating something out. Again, you're not changing what you have. You're just taking two things apart. Typically, impurities in water is an example of that. Cutting something is also an example of a physical change. If you cut it in half, it's still the same thing. Changes in state are also physical. These are the ones that can be very confusing. But if you boil water, remember that if you have liquid water when you start to boil, when water boils, it evaporates and becomes steam. Steam is still water. So it's the same substance, it's just in a different phase. It's just spread out further. The particles are just further apart. So it's still water. Condensing is the same, it's just the opposite. It goes from steam to liquid. So again, it's still water. And freezing and melting are the same way. If you have an ice cube and it melts, it's water either way. It's either ice in a solid form or liquid water in the liquid form, but it's still going to be water. Chemical changes do produce something new. And so here's some examples here. Rusting, we talked about again with the nail. If we have iron exposed to oxygen, we get iron oxide, which is rust. That's something new. When we burn something, we end up with ashes and smoke that we did not start with. Metabolizing food. When we eat food and put it into our body, it looks much different when it comes out of our body than when it goes into our body. Oxidating or reducing, those are two different types of chemical reactions that can happen, and anytime we have a reaction with oxygen. So if you see that word react or reacting or a reaction, we know that a chemical change has occurred. So some signs that we might see when we have chemical changes: a gas is produced, so typically we see bubbles. An energy change, so if something gets hotter or colder, that's typically a sign that bonds have been broken and a chemical change has taken place. Color change can sometimes be chemical. It depends on the situation, and this one you have to be careful with. If I just take food coloring and I put it in water, that's not a chemical change. But if I take two different substances and mix them together, when they react and they give me something in a different color, that would be chemical. When light or heat is given off, if we see flames, and then a formation of a precipitate. So what that means is when we take two liquid or insoluble substances, we mix them together and you get a solid that typically sinks to the bottom. That's going to be a precipitate. So you know you ended up with something new if you start with two liquids and you end up with a solid. Possible signs, again, some of these, when we have gas production, bubbles are formed during boiling, so you have to be careful in that case that you know it's boiling and it's a physical change, not a chemical change. Getting hot or cold, a lot of times are chemical changes, but we have to be careful again with those phase changes or those changes in state. When we're boiling, yes, we're making it hotter, but it's not changing what it is. If we have a reaction and it gets hotter, then it's going to be chemical. And then that color change, like I talked about. If you're just dissolving something, it's not going to be chemical, it's going to be physical. So how do we know for sure? Well, we measure and we observe. We look at those properties. We measure and observe the properties after something happens. And if the properties are the same, then it's physical. So the example of boiling again, if we would measure the properties before and after you boil water, both the water and the steam are water, so that we have not changed what we have. Also, if you can unchange what's been done, then it's going to be physical. So if salt is dissolved in water, seems to disappear, but you can unchange that and get that back. You boil the water off, you're going to get your salt back, and so that's a physical change. The water is just evaporated and the salt is left in the container. It's a physical change. Okay, again, because the original change was undone or unchanged when you boiled off the water, so dissolving is going to be physical. So anytime you can get back what you started, it is going to be a physical change. Okay, so sometimes things that are going to be confusing. We talked about how phase changes are physical. So melting is an example of that. We go from a solid to a liquid, but for example, if it's ice and water, those are both water. Burning is another one. Burning is a reaction. We get oxygen reacting with something to give us carbon dioxide and water, and so that is a new product, so it's going to be chemical. Dissolving, again, we've talked about a couple times when we add one substance to another to get a mixture. Mixtures can be separated, so when we separate those back out, we end up with the same thing, so that's going to be physical. And something drying, that's evaporation. So again, that's another phase change. We start with water in a substance and it evaporates out. It's still water. So that's a physical change because again, it's just a phase change.